Welcome to our series on vectors. We will find a resultant of two vectors parallel to the third vector in a very simple way. I hope you will understand and appreciate it. Enjoy the journey of learning. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are taking examination style test question based on vectors. We'll find the resultant vector which is parallel to a given vector. And I'll show you a very simple solution with very effective strategy in this particular video. I hope you will appreciate it. The question here is the resultant of vector A, which is 3i minus 5j, and B, which is 2pi minus pj, is parallel to the vector C, which is 2i minus 3j. Find the value of p and hence the resultant of the vector A and B. So let's first try to understand the question and then we'll solve it. So we are given two vectors. Vector A, normally we'll write with the bar on the top or it is written bold. Vector 3i, right? I are the unit vectors along x direction minus 5j. Vector B is 2pi minus pj. Resultant means you add them up, right? And so A plus P is parallel to the vector C means it is a scalar multiple, right? So let's say K times C. Is that okay? K times the vector C. So that is what we need to figure out. Now, adding the vectors A and B, let's write it in the column form. See, column form is very easy to work with. So when I say 3i-5j, so A is 3 minus 5. You get the idea? Plus B, which is 2pi minus pj. So it is 2p, the coefficient of I, minus pj. So minus p. Makes sense? Equals to some k, scalar multiple of C, which is 2i minus 3j, means 2, 3, minus 3. You get the idea. So writing in column form actually helps you to visualize and answer this question very easily. Also, you will notice that in junior levels, for example, GCSE, when vectors were introduced to you, you were working with the column form. And now at a higher level, we can still use the same concepts with which you are so familiar. That's the whole idea. Now, let's add them up. So, let me take it on this side, adding them up. So, we get what? 3 plus 2p and minus 5 minus p is equal to some constant k times 2 minus 3. So, I can write inside also scalar multiple 2k minus 3k. Make sense? So that results into two equations where we have two unknowns. Let's solve these linear system of equations. So the first one is 3 plus 2p equals to 2k. Let's call it 1. The second one here is minus 5 minus p equals to minus 3k. So these two systems. We need to find the value of P and hence the resultant of the vector A and B. Remember, the resultant is the vector K times C. You get the idea? So means you have to find K also. Perfect? You have to find K also. So now you can eliminate any one of these. So I'll prefer to eliminate P and find K first. So what I'm going to do is multiply the second equation by, let's say, 2, and then we will add them up, right? So multiply this by 2. So if I do that, I get minus 10 minus 2p equals to minus 6k. Makes sense? And then we are going to add this equation, which I am calling 3 now, with equation 1. So we'll add equation 1 with equation 3. Make sense? So when you add 3 minus 10 is minus 7. 2p minus 2p is 0. We get the value of k, right? So which is minus 4k, correct? So let's do it on this side. So k is equal to 7 divided by 4. Negative, negative cancel. So k is 7 divided by 4. So we get the value of k as 7 divided by 4. We can also find the value of p, right? So the value of p from the second equation, from here, we can say the value of p is equal to, taking p to the right side, 3k minus 5, which is 3 times 7 divided by 4 minus 5, right? So 21 minus 20, taking 4 common denominator, will give us 1 over 4, correct? So we get the value of p as well as the value of k, correct? And now you can find, so we have done one part, which is p, and hence the value of a plus p. A plus p means we only want to find the resultant, correct? Okay, so p is 1 by 4 and k is 7 by 4, both positive. So let's move on to the next page. So we just found that p is 1 by 4 and k is 7 by 4. So the resultant, let's call this resultant of a plus p is k times vector c, since it is parallel to this, right? So 2i minus 3j, correct? So which is 7 by 4 times 2i minus 3j. So you can revert back to this Cartesian form of vectors where I is unit vector along x and j is unit vector along y. So this video is kind of a bridge between what you had been using earlier and what you're going to further use most of the time. So we get this resultant vector, the sum of a and b, which is parallel to c as 7. When you do 7 times 2, 14, divide by this. So you get 7 by 2 I minus 21 by 4 j. Makes sense, right? So that becomes the resultant vector, which is a plus b, and that is parallel to vector c. So I hope the concepts are absolutely clear, right? So what we did for ease is that we wrote the vectors in the column form, added them up, applied systems of linear equation solution types, eliminated, found the value of k first, then p. And once we know both p and k, we can actually find the answer. Well, sometimes you may be asked to find what vector b is. You can substitute the value of p and rewrite vector b also, right? Let me rewrite here. So it will be 2 times 1 by 4i minus 1 by 4j, or it can be written as half I minus 1 by 4j. Makes sense? So we got the value of vector b also. I hope it makes sense. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. In case you want to study from me, you can always send an email on globalmathinstitute at gmail.com. Thanks for your time and all the best.